actually go and look up George Foreman? Huh? He has a bunch of kids all in there. You guys took it at face value. No one looked it up? No one looked it up?
Why would you lie to us?
Why would I lie to you? Some people do. All right, anyways. Okay, so with transition metals, it's the same situation as at George Foreman's house, right? So George Foreman had like 8 children and named all of them George, all right? So how do you take 8 family members that all have the exact same name and tell them apart at the kitchen table or at Christmas time? Right, you number them. So that's kind of what happens with transition metals here, all right? So, for example, there's 2 different versions of iron. There's iron that has a charge of 3+, and there's iron that has a charge of 2+. And so if either one of these irons reacted with oxygen, you would end up with 2 different formulas. All right? So if you start with the iron 3+, you would end up with the formula Fe2O3. If you started with the iron 2+, you would end up with the formula FeO. These are completely distinct compounds. They have different chemical properties. They have different physical properties. And if you follow the rules that we applied before in terms of naming them, right? So you name the metal, and then you take the non-metal and tack on "-ide", you would call this iron oxide, and you would call that iron oxide as well. And that name alone would not distinguish one from the other. And so what we have to do now for these substances where the first element is a transition metal is now we have to add something in the middle. And what we're adding in the middle is a Roman numeral. All right? What does the Roman numeral tell us? The Roman numeral tells us the charge on the metal. So actually, it's a lot easier to name things with transition metals than to name them without. Because if you have an S or P block metal, you have to memorize the charge, right? You have to memorize that an alkaline earth metal has a charge of +2. With transition metals, you don't have to memorize them at all. They tell you what the charge is flat out. It's in the name. Okay? So let's practice a few. Let's figure out how to... you okay? Write formulas from names, and then we'll go the other way. Okay? All right, so let's write some formulas. We get a pen that works. All right, so here's a name. Lead 2 sulfide. Huh? That exists. All right, how do I write the formula for lead 2 sulfide? All right, well, what did we do before when we had the name? We wrote the ions, we crisscrossed, we reduced. What are the ions present here? What's the first ion in this name? Lead. What charge does it have? Well, beats me. I didn't memorize it. Do I need to memorize it?
Yes.
No, I don't.
We have a chart.
What's that, Caitlin?
2+.
It's right there. You don't have to memorize the charge for a transition metal because it's right there under your nose. That's what the Roman numeral is. So this is lead 2+. All right, what about sulfide? What is sulfide? Is it on this polyatomic ion table, or is it just the element? It's just the element. What's the charge on sulfur? 2-. If I crisscross, what's my final answer? PBS. And I showed you a little shortcut the other day, right? Instead of having to crisscross and reduce, what did I tell you to do?
You reduce them.
You look at the charges. If they're the same value but different sign, you realize that they cancel out. If your charges cancel out, just shove the letters together. Okay, let's look at another one.
How do you know
The metal's always positive. Okay? All right, let's take a look at another one. Lead 2 cyanide. If I have to write the formula for lead 2 cyanide, what's the first ion there? PB. Where'd you get the 2+ from? From the Roman numeral. You don't have to do any work. It's right there under your nose. You didn't have to memorize anything. What's cyanide? Cn-. How do you know? Because you memorized it. It's on this table. You're going to have a quiz on it tomorrow. When I crisscross this business, what's my answer? Well, wait a minute. What are you supposed to do to these polyatomic ions before you crisscross? What did I tell you to do? Put parentheses around it. And so now when you crisscross, what do we end up with? PB, parenthesis, CN, parenthesis, 2. All right, let's do another one. Iron 3 chloride. Oh my gosh. Okay. What's the first ion there? What's the symbol for iron? Okay, well, what's the charge for iron? 3. Okay, how come? It's right there. All right. Chloride. If it ends in I, is it on this paper or is it up there? It's on the periodic table. So we're talking about chlorine. What's the charge for chlorine? 1 minus. Crisscross, what do we get? FeCl3. Okay, one more.
See, this is, you guys know your periodic tables out.
All right. What is that number? No, that's not 5.
Wait, that's the symbol for light.
That's not the symbol for light. That's a 6. All right. Let's just go through the Roman numerals just to remind everybody. How do I write a 1? I. How do I write 2? I. How do I write 3? I. Okay. How do I write 4? IV. How do you write 5? V and 6? Vi. Okay. So that's a Vi. So chromium 6 oxide. All right. So what's chromium? Cr. What's the charge on this chromium? 6 what? 6 plus? What about the oxide? It's oxygen with what kind of a charge?
2 minus.
How do you know? Because I made you memorize it.
Yeah.
Right? Okay, so now crisscross, what do we end up with? Cr2O6. And now, do I leave it like that? No, you have to simplify. If you look at these subscripts, you can reduce them by a factor of 2, right? So if I simplify them, what's my final answer? CrO3. All right, one more. I lied. I can. Stuff and things. Absolutely. Pants on fire. All right. Manganese 3-phosphate. Okay, first of all, what's the symbol for manganese? You guys get this wrong all the time. Mn. Okay, Mn. What's magnesium? Mg. I have students confuse those all the time. They'll tell me that manganese is Mg and magnesium's Mn. It's all right. Not a huge issue, but you need to fix that. All right. In this particular case, what's the charge of my manganese? 3 plus. Okay. And what's phosphate? Hey guys, I'm recording this and I'm picking you up on the camera. Say, what's phosphate? PO4, 3 minus. All right, crisscross, what do you get? MnPO4. How come? Because the charges cancel out, just shove your letters together. Okay, I can't stress how important this is. This is 3/4 of your next chapter test. Before the 9 weeks exam. 3/4 of it is just naming and writing formulas. Okay? All right.
Will we ever have to find the charge of the
Well, that's what I'm doing now. Okay, that's a little bit tougher. Okay? So now let's go backwards. So let's write names from formulas. Here, I'll put it under the document cam so you can see it. Were you there? Okay. Okay. Awesome, thank you. All right, let's take a look at something like this. We're going to start easy. We're going to start with the binary things, and then we'll throw in the polyatomics. All right, so let's start with FeCl3. I have to come up with a name for this. Well, wait a minute. First of all, is it ionic? Yes. How come? Because the first element is a metal. Okay? All right, now, what kind of metal is it? Is it an S? It's a transition metal, so it's not an sp metal, right? So, and how many elements are there total in this? 2. All right, so because there's 2 elements total, what do you know you're going to have to put in the end of the name? Ide. And because it's a transition metal, what are you going to have to put in the middle of the name? Roman numeral. Okay? So you know you have to use a Roman numeral. You know you have to use I. All right, so let's start. This is iron, Roman numeral, chloride. Okay? So now the question becomes is what is that Roman numeral that you put in that middle? All right? And so, do you remember when we came up with the subscripts, we had to do the crisscross?
Yeah.
If you want to come up with the charges, undo the crisscross. And you're right. So if I were to undo the crisscross, I would predict that the charge for iron is 3 plus and the charge for chlorine is 1 minus. All right, now, before you go with a 3, what I want you to do is undo the crisscross and double check that that in fact is the correct charge for chlorine. Is it? Okay, so if this checks out, then that checks out. So what do I put here in the middle? A 3. So this is iron 3 chloride. Okay, let's do another one. Okay, PbCl4. Okay, so Pb is lead, right? Is it in the D block? So what am I going to need in the middle of the name? Roman numeral. Is it binary? So how do I finish off the name? It would be chloride. And now the question becomes, what's that Roman numeral in the middle? So you undo the crisscross. You would predict that's a +4 and this is a -1. Is that in fact the correct charge for chlorine? So if this one checks out, that one checks out, that's a 4. So that's lead 4 chloride. I'm going to do something different. Okay, all right, let's take a look at another one. Something trickier. PbO2. All right, so again, look at the first element. Is it a transition metal? Yes, so what will we need in the middle of the name? Roman numeral. And if it wasn't a transition metal, then what? Just leave the Roman numeral out, right? Okay, what about the second half? Is it just an element?
Yeah.
So how do I finish off the name? Oxide. Now, just put your pencils and watch. Let's undo the crisscross. If I undo the crisscross, right, I would predict that the charge for lead is +2, and then the charge for oxygen is -1. All right? Yeah, I had to turn the light on. The contrast wasn't good enough. All right? That's just undoing the crisscross. Is that true? Is the charge for oxygen really 1? It's wrong. So if that's wrong, then I can't trust that. Now, what could I multiply this by to make it correct? So if I multiply this by 2, guess what I'm going to do to the other one? Multiply it by 2 as well. So what is the charge on lead? 4 plus. It's IV. How come I had to do that? Because, what's that? It's a simplified formula, that's why. Okay? All right, let's do another one. Let's add polyatomics in the mix now. You want something besides lead?
And let's start with that tech.
Okay. FeSO4. Is that first element a transition metal? Yes. So, how's the name going to start? Iron. Do I need a Roman numeral? Let's leave it blank for a moment. And then what's this SO4 thing called? Sulfate. How do you know? You memorized it. It's on that polyatomic ion table. All right? And now the question becomes iron what sulfate? All right, this is tricky. Watch. What's the charge of sulfate? No. You memorized it. What is it? 2 minus. What does the charge of iron have to be to balance it out? 2 plus. What's the Roman numeral here? 2. Why does the charge of iron have to be 2 plus? Because the sulfate is 2 minus, and charges, when they come together, what do? They have to cancel in the final formula. All right, let's do another one. How about this one? Fe2SO43. That exists as well. Again, is that a D block element in the front?
Yeah.
Yeah. So how does the name start? Iron with a Roman numeral of some kind, right? What's SO4? Sulfate. Because you memorize the name. Okay? I don't hate you. I do it to you because I love you. Huh? Sometimes love is rough. Okay? All right. So, you don't get it. Okay. Now we got to figure out the charges. Okay? All right. So let's undo the crisscross. This would be 2 minus. This would be 3 plus. All right? Is that in fact the charge for sulfate? Is it correct? So then if this is correct, is that correct?
Yeah.
So this is iron what?
Iron 3.
Iron 3 sulfate. Okay. Let's keep going. NiClO3 2. All right. First element. Is it in the D block? Yes. How does the name go? It's nickel, parenthesis, and then what's the ClO3 called? Chlorate. Question is, what's the Roman numeral? Okay, let's undo the crisscross. If I undo the crisscross, then I would say that nickel's 2 plus and chlorate is what? 1 minus. Is that in fact the correct charge for chlorate?
Yes.
Yes. So then that must be correct as well. What goes in the Roman numeral? A 2. Okay, another one. I just undid the crisscross. You undo the crisscross, and then you just double check that the charge on the anion is correct. If it's not, you multiply by something to make it right. And whatever you multiply the anion by, you multiply the cation by 2. Okay?
So what did we move by?
No, this one was right. What's that? Okay. Let me show you another one. AlPO4. This is a trick. What's this called? Aluminum. Do I need a Roman numeral?
No.
No. How come?
It's not in a transition metal.
It's not a transition metal. What's that called? Phosphate. Oh, man. What about this? I am. FePO4. That's iron. Do I need a Roman numeral? Yes. What is it? It's a Roman numeral. And what's PO4 called? Phosphate. No, it's not one. Okay, maybe it would help. Remember when we were doing the crisscross, I told you to put parentheses around the polyatomic? Maybe it would help us to put parentheses around these before we undo the crisscross. Right? So let me put a parenthesis around the phosphate. Right? If I undo the crisscross, so the number outside becomes the charge for the iron, what would that be? 1 plus. And the number behind the iron becomes the charge on the phosphate, what would that be? 1 minus. Okay, and you take a look here. Oh no, this has a Roman numeral. Okay, you undo the crisscross, you would predict that this is 1 plus, you would predict that that's 1 minus. The question is that correct for phosphate? No, it's not. What should it really be? Should really be a 3 minus. So let's multiply this by 3, and if we multiply that one by 3, I have to multiply this charge by 3. What's the charge on iron? 3. Okay? Alright, and so this is how we do these things with the Roman numerals. Okay? Alright, so what if we take a look at the page 275, questions 12 to 17? How was it? Yeah, I kind of needed to teach it to you. All right. So let me walk around, check to see how much